Welcome back to the workshop, and welcome to this ongoing quest to make some small improvements to this drill press. Recently in this video series we've added this motor and this lift system so you can raise the knee up and down automatically. And in the previous video we made a start on the enclosure that's going to house all the electronics to control the motor. So in this video I think we need to finish off that enclosure and get some motion out of the knee. Let's get started. So before we get into this video properly, in terms of modifications to this, actually there's more modifications than original parts now, to be honest. So anything green, like the head unit there, that's got the quill assembly in, that is from the original drill, but everything else, three-phase motor, belt drive with a two-stage system there, the custom control cabinet, lighting, all the linear rails, the XY table, the knee, the DROs on all axes, and the motor, of course. They're all things I've added since, and then there's another green item, so that's on the original part, and there's the bottom of the column, which you might be able to see back there. I think it's about an 80mm column, you know, standard thing on a drill press. Everything else I've upgraded, so I guess it's less original and more modified, but anyway, that's where we currently are in the project, and we're just trying to add this motor system to lift it up and down and just make life a little bit easier. And I think we should cover some other points before we get into the video properly. Obviously you can see from last time I've gone ahead and I've sprayed it. No, we're not allowed to say gone ahead. I've made a start and sprayed the cabinets grey. So I used a zinc primer from Screwfix just to get a nice key, and then I've had a couple of layers of this furniture paint from Rust-Oleum. It gives quite a nice finish. I think it looks okay. The door I think probably needs one more sand down and one more coat just to make it a little bit nicer, but we can do that another time because I need to focus on the base over there. So speaking of YouTube videos, I think at least one person pointed out a slight error I made in editing last time, so apologies for that. When we cut to machining this part, which is the lower bit here, I accidentally inserted the footage of machining this part again, but just a different area. You can see this sort of looks similar. Yeah, so I messed up there. So as I'm sure you know, when you're making YouTube videos, it isn't real time. You tend to do a session in the workshop, you machine a load of footage, and you try it, then you get back to your computer and you put it in different folders, and I just mixed them up. You know, they look similar on the little thumbnails and I put the wrong bit of footage in. Obviously it's covered in swarf as well when you're machining and so on, so apologies for that. So for those of you who missed it and want a bit of a reminder of what that would look like, here's that footage. Hopefully you're satisfied now. Right, onwards. Okay, last one in terms of comments and useful information I think it's worth sharing. You probably saw me 3D print a load of different brackets and things for holding various parts in the enclosure, including this one here that clips around the front, and it had some holes. So the idea was you'd screw this in first onto the board, and then there's one at the back as well, and you would slide the power supply in. Now firstly, I realized that was actually going to be quite awkward to do that. These were not easy to slide in the first place and get everything clipped in. They're quite a tight fit. And so I ended up reprinting those. They look like essentially this. So now the power supply will sit and finish here, so you'll be able to clip them in, you know, out here, and then we've got the screw holes to screw them in. So we've got one at the top and one at the bottom, and sort of be like that. And then on one of them, it's that one there, has these little features in it that actually hold onto the unit, and just here and stop it sliding down, so it will always hold like that. So I thought that was a good step forward and a better way to hold it, but I had a great comment about PLA and about the fact that at elevated temperatures you can get a creep effect on it. So if you've got a mechanical load on it and it starts to get warm, it will start to deform and take a different position. And for an electronics component, especially this one, inside an enclosure, this one's going to have power down here. You know, worst case it sort of creeps down and comes down, then the power hits the bottom of the metal plate. Yeah, you don't want to go there, do you? So the advice was to go with something a bit more of a technical solution. So PETG, ABS, possibly ASA were recommended. Also the ones where you have the carbon fibre additional fill. I need to be convinced that the carbon fibre is worth like extra, because the fibres are going to be quite short, so it's not going to be the same as carbon fibre as in a sheet that you impregnate and put into a vacuum chamber, you know, like racing car tubs and so on. But certainly perhaps not a best idea to use PLA if it's going to get warm in an enclosure and so on. Now I did find a link to a very useful video, like a technical video by a guy, I think Tech Guy, but I'll put the link in the description below. He creep tested a range of materials. Again, you can, I think PLA was one of them, probably ABS and polycarbonate, I think. Can't quite remember. It was quite interesting there. So yeah, as soon as you get to 30 degrees and above, you got a decent amount of load on one of these, it will probably start to deform. So I've got a bit of a plan, which is I'm certainly going to go ahead and use these for now. And obviously, because this will be up here like that, with gravity trying to pull it down, what I've printed out is these two blocks. So they will sit just there like that. And again, you can say, well, that will creep, but I think that would be okay because you're pushing directly against it. So that will hold a lot of the vertical load. Of course, it could still come out over time. The reason for that kind of temporary fix is I've bought quite a few filaments. We've got black, white, grey, yellow, green, orange, and they're all Bamboo Originals, which are the more pricey because they have the RFID tag. And my wife's watching the expenditure on this bit of the hobby at the moment, so we'll hold fire on getting the PETG. I think for now we'll do that, get it working. All the wiring will be complete, so to swap them out for an equivalent PETG design will be a very short, few minutes, just swap them over. So we're going to do that, get it going, and then we'll do something better in the future as a bracket, in the near future, let's say. Okay. Now I think that logic extends a little bit to the hinges, which are again were PLA. I was quite pleased that I'd managed to produce these print in place types. It's amazing, isn't it? You got the pin is captured and printed along with it, and as long as you put a bit of support material, you get a workable hinge. But again, they're going to be carrying the load of the door and the control panel and so on. So although these are probably not going to get quite so warm because on the outside, I wasn't totally happy with it. So I went to Screwfix and got these are actually brass hinges, and I've just sprayed them a little bit. I'll give them a final coat. These are metal, and they'll go on, and I think they'll do a good job, and clearly they won't creep down over time as well. So again, we can look at that later once we actually get the door on, but for now we need to focus on getting the electrics sorted. One of the other components that's PLA is the distribution box, but this is just going to sit like that, and I'll have just some wires going into here. I don't think this will heat creep, there's no real load as such on it, so I think we'll keep that as it is. So this will have 5 volts, 2.5 volts and 0 volts. So 5 volts the Arduino, and there's a few more things that need that. We'll come back to the 2.5. The 0 is for grounding. All the DC is going to be grounded together, so they're not floating independently. And then the 2.5 is because I'm going to use just a single channel input on the Arduino, and it will just read a voltage that's somewhere around 5 volts, so about 1023 Arduino units, somewhere around 2.5 volts, which I think will be 512, and somewhere around 0, so 0 units. And the reason for that is I've got a 3-position switch here, 1, 2, 3, and this is for which, this goes in here, which option have you selected: continuous, intermittent, or pulsing, or steps, I guess you call that, and the can drill cycle on that one there. And it's a neat, easy way, rather than using up 3 inputs, it'll just have those 3 steps. And then to do that, I'll just put 2 10k resistors either side and drop the 5 volts down to a midpoint. The current will be trivial, and so they won't get very warm at all, so I think that will be fine. So even with relatively simple projects, I always like to do some kind of wiring diagram, mainly because you come back to it in a couple of years because something stopped working and you just can't remember what you've done. So hopefully this will help me out if that is the case. There's a couple of things you can see here. One is, I spilled coffee on it. for one, and two, my laser printer's running a bit low on toner, but hopefully it's clear enough to give you a rough idea about what's going on. Okay, in terms of the basic layout, so we've got two 30 volts coming in, and then we immediately come back out with that as well, and that will go off to the DRO. So when you switch this on and put power to this, the DRO will come on as well, so they'll share the same plug and socket. So we've got our 48 volts DC, 24 volts and 5 volts. So in terms of the 48 volts, that's needed to run the stepper drive that's over here. So that's our basic 524, and that will take us out to the stepper motor via these connectors on the panel, and that will drive the knee up and down. Then the 5 volts DC runs a couple of things, some of the logic, but also the Arduino needs 5 volts, which is in here. And then the last one is the 24 volts, and that's needed to run the stepper brake, so we can release the brake and hold the brake to stop the knee sinking when there's no power or you're drilling and so on. And then everything else, so this switch gear at the top, that's on the main control panel with either two-way switches, press switches, whatever. You'll see the voltage divider in here to give us our 5 volts, 2.5 volts and 0. So we can differentiate between the three conditions on the switch there, LCD and keypad, in the usual way that you'd wire those up. And then you probably can't see that, but they're all the analog and digital channels on the Arduino. And the last thing to share is there's a bit of control on a relay here. So the Arduino will control the 5 volt relay, which controls 24 volts going to the stepper, so the Arduino can control the brake coming on and off. And then in terms of inputs, you've got the upper and lower limit switches, just the switches on the knee, so it knows when it's reached the top or the bottom and it doesn't go any further. I think that's essentially it. So that's a quick overview of the wiring that we've got. So the other thing I printed out is just the layout. So I've just taken a few dimensions off here. It just means I lay it out once and I haven't got to adjust it and have multiple screw holes if I get to the end and realise I haven't quite got enough space. And then the other thing is I've swapped these over. So these are now the ones where they're clipped in and I can screw them in from once it's already clipped in. I haven't got to screw underneath and then clip these into there, so that will make life a bit easier. But as I said earlier, I will swap those out to PETG or ABS or something a bit more of an engineering material, but for now I think that will be fine. Okay, let's get it roughed out and start screwing some of the bits down. So in the last video I did get called out for using the wrong size bit for some of the screws, which, yes, guilty, I did do that. Some of the really small ones starting to get a little bit chewed in here, but I've had another look through. As you can see, I've got quite a few. So we've got the Phillips posi drive, obviously they're slotted there, the other type, so it's the screws I'm using are one of these two types normally. There's some down there, got some DeWalt ones as well. So I've had a little bit of a better look, and actually I've got quite a, let me see, it's worn ever so slightly on there, it's not too bad. And that's a posi drive 1. Focus. That's quite a nice fit in there, so we'll go ahead with that. Yeah, sorry about that. Okay, so as you can see, we've got all the power supplies in, the stepper driver, the Arduino behind here, and then there's 2 relays on there. I only need 1 of those, but I thought I may as well put 2 on just in case I want to do something else in the future. And then that relay will send 24 volts to the brake, so the Arduino can control the brake via that relay. We've got all our trunking in, and I've removed all these little fingers here so we can get the wiring all the way around. And then right at the beginning you saw me put, this is going to be earth, so all the earths will be starred at this point. So I guess it's trying stop you having little individual earth loops. Probably on a system like this might not be required, but yeah, it's good practice anyway. And I think that's, oh, and the distribution box right at the top there. I think that's all the sort of the hardware installed. Now we need to start the wiring. Okay, so I've got my tools ready to go for the electrical stuff. I've got some other switchgear that's going to go in. We've got some fork terminals. I'm running a bit low on the white ferrules on here, which go in the 0.5mm cable, which is what I've got here. Ordered up a couple of different colours, 5 meters of each. They should be here today or possibly tomorrow, so I should be able to progress with that. I think that's it for now. Yeah, let's get going. Okay, quick update then. So we've got our mains line coming in, distributed to live, neutral and earth, and then we've got that coming back out again. So that goes out to this one, which will plug into the DRO. So once we power this up, both of them will come on. I've decided the whole thing, this unit and the DRO, are going to run off the single fuse that's in the plug, so I'll probably run off like a 3 amp, something like that. Rather than get really complicated and fuse individual bits here, I think it's going to be such low current anyway. We'll just run it off that small low fuse, and I think that will be fine. And then you can see down there I've bunched all the earths together. They come off that same terminal block. There's a couple of spare there just in case I need to shield the motor or anything like that. Now typically on a enclosure I'd have distribution blocks for the live, neutral as well. But I think in this case, again, because such low current, I've essentially just daisy chained one off the other. Now they will all be drawing off the same cable, but the cable's pretty thick compared to the current we're going to draw, so I'm happy to do that. So I think what we'll do now, again working away from this corner and moving our way around, we'll get the 48 volt DC wired into the driver. Okay, these GX16 connectors are great. You can get them in multi-pole from 2-pole all the way up to I think about 10. One thing just to be careful, make sure you don't make the mistake, which is to feed the wires through the panel and do the soldering out here, and then make sure you got the nut on the other side and your heat shrink as well, or solder the wires on first somewhere over here and then feed them through and feed everything else on. You know, just work your way around that way. Don't forget to put the nut on, and don't solder them here, and then obviously you can't pass them back through. Ask me how I know. Yeah. Okay, quick update then. So we've got all the mains wired in for the 48 volt, 24 volt and the 5 volt supply. We've got all the logic signals coming from the Arduino behind there out to the relay and to the stepper motor, and then we've got the wires from the stepper motor coming down to, I think it's this GX16 connector here. So here's our mains connectors coming in and going back out again to the DRO, and then we've got those looped out to the 24 and the 5 volt supply, so they're done. We've got all our star earths connected together down there, and then we've got our DC coming out of here, 48, 24 and 5 volts. And then here's our stepper, it's wired in, we've got the power, we've got the two signals to A and B on the coils, and then we've got the step direction and enabled all sorted out as well down here. And then we come back over to the Arduino, so we've got some of that wired in now, so we've got the 5 volt power supply wired in down there, we've got our step direction and enable, and then we've got this connected down here that goes out to the relay, that's to control the brake. Now I've had on order for over a week now these little white ferrule crimp terminals down here, and I think they only sent them out yesterday, although I ordered them over a week ago. It's from a UK supplier, so a bit annoyed they haven't arrived yet, so I've just pushed the wires in for now. We'll sort those out a bit later, and then because these are the signal wires and it's not obvious what they are, I've just got the little heat shrink labels on there for the enable, step and the direction. Okay, you'll also notice I've got the metal hinges on now to replace the PLA ones so they won't creep down. So I think the next thing to do is turn it on, make sure we get 48 volts, 24 and 5 volts out, and that everything lights up as it should, and then we'll check the distribution box over here to make sure we got 5 volts and 2.5 volts. Here we go. That's a good start. So we've got green light on the 3 power supplies. Can't see it, but there's a red light on the Arduino back there. All the fans has come on. Alright, let's check the voltages. I'll check the driver. Should be 48. 51. Alright. Just turn that down a bit. And next we'll check, we've got 5 volts and 2.5 volts here. So should be 5 across there. 5.2 and 2.5. Yeah. Okay. Okay, being a little bit careful because we've got mains right next to it. We've got 19. Okay, 23.6, that'll be fine. Okay, so far so good, so we'll turn it off, close the lid, and then we can get some of the switchgear connected up as well. I'm just wondering if it's better to put this in the door and then wire it up, put all the connectors in, or wire it up out here. I think I'll put it in the door. Now these two went in okay, and these are the type I've used many times. This one was an eBay special, but this one is a Schneider. I picked it up for a few pounds and it's really nice. It's got all metal construction. It's got a nice click action, way better than the the type you get with these. Only thing is, well, two things really. This bit sticks out, so I've had to just chisel that a little bit away. That's no problem, but just get the front off. Yeah, this is between here and here is now too thick, so I can't get it to go home. Doesn't quite click, so I have to reprint this and then have that tab around just the center two, and then this one will just have to be cut off there, and then this can go directly in. Is that gone? Okay, that's in, and then how did it go? Pull, I think, was it? Oh man. Go. Hold on, let's do it again out here. So I know what I'm doing. It does have top written on it, which is... Oh, hang on, we got that as well. No, okay. And then... That's top. Okay, looks quite square. I can get the cables in. And then... Alright. And about 45 minutes later, we got a new one printed out. So I've got the new hole there for the potentiometer, as you can see. I'll put that little ring around it as well, just to give it some depth to sink into, and then that's the anti-rotation pin. So that worked out okay. I've moved, I think it was that hole is now there. It's had a little bit of strength as well. The only thing was, I didn't notice because I left it running, but it became a little bit delaminated from the board, and it's just messed up that corner, but that's okay because you'll just see that part there that sticks through the hole. So I think we'll go with that. We'll just try it and see if it fits, and see if there's any more modifications we need to make. And then while I was at 3D printer, I've just designed some little standoffs so they will hold the keypad and the LCD screen onto the unit as well. They'll just go on, I think, yeah, that one's on there like that, just spaces each end for both those. Right, let's get this fitted. Okay, while we're getting on finishing that, I thought I'd 3D print a cover to go over here, and design that last night, and it took about 3 hours, so I just left it running overnight. And then in the morning we got this. So it was printed that side down. So initial glance, it looks quite good. I know it's hard to see the black on the camera, but that's really super smooth. That's great. And I built in these little kind of hooks here, so it would kind of clip on at the back. And then we've got some more clips at the front, so it would clip around here, so it just sort of snap fit on. And then you can see the support material in there, which will break away in a minute. So superficially it looks quite good. Also got some little posts in there, so when it sort of goes over the top, it will sit onto those in each of the corners. Down there, and then got a little slot there, so we can just offer it on. The idea is it should just, obviously got the support material in the way, hooking over the back, and then at the front here just clip on over that and snap into place, and that should be it. And that, obviously it's too high at the moment, but that will look quite nice. Yeah, quite pleased with that. Obviously we've got to do something with the cabling and routing down here, but just for the belt, I thought that would work quite well. I wasn't sure if I was going to have enough clearance to that, and I thought it was going to be a bit close, so what I might have to do, yeah, it does look it's going to be a bit close. I thought what I was going to have to do is replace that just with a standard little, like a grub screw or a little cap head screw, just to keep the dirt out. But anyway, so it looks okay superficially, however, there are some issues. So I knew with a part this size, it just about fits on the bed. You've got to probably, well, this is about 240 long, and the whole bed's 256, so you're only just on with about 10 mil each side, and I don't know how far the kind of heating elements kind of really go. Yeah, if you get to the edges. That was one worry I had. Also, with such a big part like this and such a deep section, when it cooled, I was fearing that it would pull, and you can see what it's done there. I don't know if that's obvious on camera, but that's bent up quite a long way. Obviously it's the bed, so it's pulled away like that, and then the same, oh yeah, you can see it down there in that corner. Again, that should be flat like that, and it's pulled away. So it's at the edges where, although I put an 18mm brim, and also got all this adhesion as well on the brim there. By the time you get to the front, it was maybe 8-9 millimeters, and when it it got about to there, I think, and I was starting to worry that maybe it was starting to come loose. I couldn't quite fully tell, but yeah, got up in the morning, had a look at it, and it's done that. Anyway, I think what we can do is take the supports out, check if it clips in, just make sure it doesn't hit anything and it's basically going to work, and then yeah, I'll have to think about what I can do there. I can't print it diagonally because it's even worse. Definitely really gets very close when I do that. Some other options are purposefully cutting some, I think, probably vertical slots in the part. Not enough that you can get your finger in, but enough so that it just can't contract and pull. It sort of breaks the linkage. Just maybe that might be an option, but I don't know. We'll have a rather think. But anyway, let's get the support out and see if it clips into place and at least kind of functions, and then I'll come back another day and have a think about that. So I'm quite new to 3D printing, so I don't know if there's a good way to do this, or you just use whatever tool works. Oh, okay. That was well worth doing. I was worried it was going to leave a residue. Hopefully you can see there. This extends out, so it should snap fit into place. I'm not really sure how much, how much geometry to leave to create that snap, how much is too thin, what is it happy to print, or what will just break. So it's a bit of a lucky guess at the moment. Guess I'll learn more and then take it from there. Sort of looks like it'll do the job. That's those. And then the two little ones at the front. And I was going to leave it just like that, and I thought the plastic will probably, PLA this is, will probably flex enough, but in the end I thought, no, let's just actually take that back. Again, don't know how much I really need. That's surprisingly therapeutic. So for now, I know I'm going to hit that, so I'll at least take that off, and might need to take that fitting off as well. Let's see. It's supposed to hook over the back first and sit on those shoulders, which it is. And if I get it on, will it come off again? Oh, I guess that was it. Just need to push a bit harder. It slides over, but it snaps. But you can push it up. If I push directly on it, it doesn't move. If I push here, yeah, it's really small. Probably need to make that stick in a bit more, but otherwise seems okay. And I don't know if you can see down there, but that is completely flush there, nice and straight. Generally pleased. Just need to sort a few issues out. We'll come back to that another time. Okay, so after quite a few hours, we've got to this point here. So as you can see, the box is now painted. I've got it back together. I've got the main control panel installed at the top there. I've made up some of the GX16 connectors. One goes off to the stepper motor, one goes to the brake. I've had to do a little bit of wiring inside just to make that work for now. I'll come on to that in a minute. Power, obviously we've got that in, and then this one would go off to the DRO, but via this IEC connector, but we haven't got that wired in at the moment. Also, I took this whole unit into the house, hooked it up to the PC, connected the Arduino up to the computer, and then rewrote quite a lot of the code, so it's added some more functionality, fixed a few bugs, that kind of thing. And I think probably the next thing to do is just to kind of basically get it all working, use it for a bit, and then see where I want to go with some of that functionality. Okay, have a little bit of a look inside. So everything's wired up. I haven't put the covers back on the trunking, just in case while I'm debugging, so a bit of a pain to get off again. But got all the voltages working now, the stepper driver's all wired in and working, with all the pulse step direction all connected up to the Arduino. So all this is all finished. We'll bring you into the corner in a minute and just show you a little thing I've had to do over there. So the first thing is this blue lead. So the way I've ended up wiring this up is, so this lead here comes from the 5 volts from the main power supply down there and goes into the central block. But when you plug the Arduino in, which is here, to the computer, there's 5 volts coming in from the USB as well. And obviously you don't want those fighting each other. So when I hook it up to the computer, I just put that blue lead and tuck it back in here. It's like a flying lead. So then it's powered off the PC via the USB. And then when I come out to the workshop to try it for real, obviously I haven't got the USB anymore, and I can plug that back in there. I guess I could have arranged some kind of switch to say 5 volt internal or external, but you know, once it's all wired up and working, and I've got the code and I'm happy with it, then that 5 volts will probably just go back up here again and be permanently wired in. So I think that was the first thing to say. The second thing was, you probably see this leads loose here. That is the pin out that went into the relay. So this relay works the brake on the stepper motor. And what I was finding was when you boot this up, the relay clicks and you're getting a little spike, a little voltage spike that obviously you get off the relays. Now I thought, I hadn't really looked closely, but I'd assumed there was a little flyback diode on here to protect it, but now looking again I'm not so sure there is. I think that is probably a MOSFET or something like that. So for now I've disconnected it because it was spiking random pulses every time this triggered into the Arduino and making this not shut down but going into a weird mode where it wouldn't work anymore. So I'm not using that at all. I've got this permanently wired in from the 5 volts, so as soon as it gets power, the stepper brake is released. I do know that this will run, the code does run, and it trips the relay and it will trip it on and off when you need to move it, so that bit does work. So I'll just need to arrange a little flyback diode on the outside here, but for now that's hardwired to be on all the time. And perhaps the last thing to say is, obviously we've got all this wired in now, so we've got the e-stop potentiometer, that's the up-down, that's the 3-position switch. Now, well, I thought it was basically a 3-position switch that give you 3 distinct outputs. It is a 3-way switch, but it's not quite what I was expecting. So these contacts are made, so you can see the green bits there, when the switch is to one side. When you go into the middle, both of them are off, and when you go to this side, this contact gets made. So it's not quite the logic I was expecting. So I'm not running the 2.5 volts on the voltage divider because that doesn't make any sense anymore. Instead I've got those as 2 separate inputs that go into the Arduino, and there's just a bit of logic that says if this one's on and that one's off, then you're obviously in that position. If both are off, you're in the middle, and if this one's on but that's off, you're in this position. And then it converts that into, well, I'm in this mode or that mode. So redid the code for that, so that's now working. And then these little connectors here, they're individual connectors. I found they were very loose on there, and it didn't take much, almost at random, the display would kind of stop working or have strange characters on it. So I've bunched those together with the cable tie there and there. I thought about soldering the wires on direct, but that makes it a bit awkward to kind of reuse it or take it out for debugging or anything like that. So yeah, that's working okay for now. But I'll keep an eye on that. Same thing on the keypad, just had to bunch those together. But otherwise that went okay. I still need to neaten up the wiring. It's just out of shot, but work out how I'm going to loop it through, so when you shut and open this, it's definitely not going to get caught, but for now it's just held with a little tie. Okay, yeah, there's a better shot of that. Just got that around it for now, and I just want to make sure that when you close it, it's definitely got somewhere for the wires to go. So I think it's going to be alright, but we'll just make sure that's going to work every time, not get anything trapped. But we're in debugging mode, so we're just keeping everything loose for now. Right, I think what we'll do then, we'll switch it on and you can see everything come on, and then we'll have a play with the control panel. Alright, so I brought you in a bit closer. So we've got the emergency stop, speed, up, down. This is our 3-position switch, so we've got continuous, which is the mode we're in currently, step, so we can go up in small steps or move the knee up in small steps, and then I've put this in just in case I ever do a drill cycle, but that will allow you to drill a hole to a certain depth with a few pecks and things like that, a little bit like you might have on a CNC machine. And then these enable you to control some of those parameters. So when you're in basic continuous mode, it's okay, it's ready to go. 64% is the speed, it goes all the way to 99, all the way down to 0. And then you got up, down, so you can't see the knee at the moment, but if I just press that, you can see you get up in the top corner, or I can go down, DO, down, and the knee is moving up and down, and you can vary the speed. You can probably hear the motor. Oh, I think we found a new maximum. That's a good point. I haven't introduced acceleration yet. It's not a huge amount more code, but it's just more work to do. I think I'll introduce that just so it's got a little bit of a ramp, and that will probably help it for this real high speed stuff. You know, one step at a time. So that's that. That's good. So the next one is we can go around, go into step. Only in step mode, and this doesn't work, so I've just got the display working, but it doesn't actually do anything. So if I was to press up, the idea is it would go up 0.1 millimeters every time you press that. I'm not sure if I want it so that you hold it and it keeps going, and then when it's done 0.1 it stops, then you have to let go and press it again. I'm just thinking of sort of safety, really, because you know, it could be. Let me just show you. So if we the up down keys add 0.1 millimeters. So let's say I think I maxed it out at 5. Let's hold that down. There we go. So you can imagine that at 5, and I just pressed that. Now it's going to keep going. And you know, if something was in the way, or you think, oh, it's going to hit the workpiece, yes, you got the emergency stop. Actually, we'll come on to that about how that's implemented and maybe what I'll end up doing. But it bothered me a little bit that would then just carry on like it does on the CNC machine, to be fair. But I thought maybe it'd be best just to hold that down. Once it gets to the 5, you let go, and then if you want to go again, you go again. We'll see. Again, just playing with it and seeing what I want to go with. So that'll be step up, step down, that amount. Let's just reset that just because we can. Okay, and then the drill cycle. So this is how far it will go down total. I've got the speed is set at 10%, so whatever you've dialed in here, it will move the knee at 10% of that. Maybe I'll put that as a parameter. I don't know. You know, how far do you go with this? And then what was the other one? Oh yeah, the pec depth. So how far do you want to go before you pause? Possibly back off a little bit. At the moment, I think that's set at 0.5 millimeter or millimeter. I can't remember. Again, could be a user parameter, but for now, I'm just going to focus on the maximum depth. And I think for this one, I went 20. I don't know how far you might want to go. Maybe I should make that a little bit further. In theory, you might want to drill quite a big hole, but I primarily probably would want to use that if I was countersinking, like you know, if you got a cap head screw and you want to set it flush, you know, that would be a very big countersink for a very big screw. Tend to use M8s as maximum, so you only need 8 really, so maybe that'll be okay. And let's say you set it to, let's say you had an M8 cap head, you might do 9 just to make sure it's definitely flush. And then the idea would be you'd press go on one of these, probably up, I guess, to lift it up, and it would drill at, and it would lift the knee up at 10% of this speed, and after a certain amount, I can't remember what it was, I think it was 1 millimeter, it would pause. If I can get it easily to run, maybe it'll back off slightly, and then it will go again another millimeter and so on until it's got to 9. Again, maybe you have to hold the button down to complete the cycle, and then it will come all the way out back to where you started. It assumes you're going to start 0 on the surface. You know, you can get very complicated with this, but I think that will be plenty good enough, and be quite fun to play with. Alright, so we'll go into continuous mode, and then we'll just move the knee up and down. So we're at about 80%, so let's go up and down. Alright, looking good. I think the only thing we didn't show you actually was the emergency stop. Okay, so you can see it's in run mode at the moment. If I hit the emergency stop, ooh, something, I think there's obviously a spike and it's knocked the whole thing out. Oh, I wonder if it's because it's disabled the driver, hasn't it? Let's see if that comes back. Well, first live test of it fully wired up. Ooh. Okay, I think I've probably upset the Arduino, so let's just reset that. Obviously going to need some filtering on some of the input pins. Has that gone okay? Okay, we're back in action. I guess it did stop. Well, let's see. Yeah, okay, so if we hit E-stop again. Oh, alright, it was okay this time, and we can't go up or down. If we change the speed, nothing happens. Change modes? No. Okay, locked out, and if we come back. Yep. Oh, we still can't. What's happened here? Alright, we have another bug. So next things we need to do, you'll see there's two holes down here. I've got the upper and lower limit switches to wire in so that when it gets to the end it will stop the movement and stop it crashing into whatever's in the way. So we've got that to do next. Then we need to make the little feet that go on here. So there'll be cylinders about that long. One from here with a thread on it, one from there. And then we can rest it against the wall on those feet, and then at the back screw the panel into the wall. We've got some holes in there to do that. We've got some spacers as well, so that will be next up. I think there was something on the E-stop that I wasn't fully happy with. Actually, we didn't get into that today. Maybe we'll show you that next time, about what we might need to do there, just to make sure that's a bit more robust. But yeah, good progress. Really pleased. So I hope you've enjoyed watching. I hope you're enjoying the series so far. If you've got any questions, just drop those down below. If you're enjoying it and you're not subscribed, feel free to do that, and click the bell if you want notification when I upload the next video. I think all that remains to be said then is thank you very much for watching, and see you next time.